Okay, this problem simply asks you to identify the x and y intercepts and all asymptotes for this function right here, y equals 2x plus 21 over the quantity x plus 7. I've put some guidelines for sketching rational functions here. I'm not going to read through all these, but you'll see that if you do read through them, that those ideas of finding the x and y intercepts and all asymptotes are included in this list. And when you get to calculus, there'll even be more steps. But for now, we're just going to find the x and y intercepts in the horizontal and vertical asymptotes. To find the x-intercept, you want to know, what does x equal when y equals 0? Because an x-intercept lies somewhere along the x-axis. That's when y is 0. So we put 0 in for y and solve for x. Now, if I put a 0 here, you could picture multiplying both sides by x plus 7 to clear the equation of fractions. But x plus 7 times 0 is just going to give you 0. And over here, these cancel out. So really, a rational function only equals 0 when the numerator equals 0. So that's another way to think about it. So we want to know, when does 2x plus 21 equal 0? It equals 0 when x equals negative 21 halves. So this is your x-intercept right here, or negative 10.5. For your y-intercept, when x equals 0, we'll have a y-intercept. So we put 0 in for x, and we get 21 over 7 equals 3. So the y-intercept is at 0, 3. Now if I go to the next board, here's a graph of the function on Desmos. I just typed in, I typed in on Desmos f of x equals, use function notation, 2x plus 21, then hit the slash key, and that on Desmos gave me this over x plus 7. And that gave me this graph. And then I also graphed these x and y intercepts, which we found on the previous board. Now the vertical asymptotes occur when the denominator equals 0. Because if I put a negative 7 in for x, I will be dividing by 0. So the function or the graph cannot cross the line x equals negative 7. That's why this is a vertical asymptote, which is this dashed vertical line right here. See how the graph doesn't touch that line or cross it. For a horizontal asymptote, this is a little bit harder for some students to understand. There are some guidelines to follow by comparing the degree of the numerator with the degree of the denominator. When those degrees are equal, in this case, the numerator is of degree 1 and the denominator is of degree 1. So the degrees are equal, so I can just examine the coefficients of those highest degree terms. That's why we can go like that and say, y equals 2 is the horizontal asymptote. Now to see why that works, I divided every term of the original function by x and rewrote the function this way. And what happens is, as x gets really big or really small, these fractions approach 0. So the limit of this function as x approaches infinity is this number right here, which is 2, which is this horizontal dashed line right here. This is the line y equals 2. Because again, if you put a number in here like 1,000 for x, you get 2 plus 21 1,000ths, that's 2.021 divided by 1 plus 7 1,000ths. That's going to be really close to 2. And the further you go out this way, the closer the y value will be to 2. Okay, this is supposed to be a 2. know why I got a negative sign there. 2. Okay, there you go. Hope that helped. If you have any questions, post a comment.